everybody? It's Tyler here at the Championships, checking in with 2468 Team Appreciate, an incredible team and wonderful performance this year. A couple district wins, as well as winning the Impact Award at DCMP. I have to admit, this is one of my favorites to become a Hall of Fame team, so I can't wait to see where they're at for that. They had a finalist Hall of Fame a couple of years ago, and definitely an incredibly impactful team here in the first community. Let's focus a little bit on 2468's robot this year. Awesome intake. We've talked about the under the bumper intake as they go through. Made a lot of changes, both in regards to their shooter coming to the DCMP and adding on the blower motor as well too. So we'll talk more about that, how it's been working out for them, and see if we can appreciate how awesome this robot is. So let's learn more about 2468 coming up here on Behind the Bumpers. Support Fun's content creators when you sign up for a membership on YouTube Join. You'll get access to special perks like emotes, loyalty badges, and Fun members will even get early access to our scheduled videos and more. 100% of this revenue will go back to our correspondents to help recognize their efforts. Click the join button in any YouTube video to pledge your support. David, let's talk about the integration on this robot, how you've gone into what you have so far, and then we're going to roll into your intake also.
Yeah, so for our robot design, in the beginning of the season, we were looking at the best ways to score notes as fast as possible. So we went with a robot archetype that was light, simple, and very modular. As you can see, we have this under the bumper intake with a 3:1 gear ratio on a Neo, and we're using a silicon wrap from McMaster. We have a lot of experience with it, and basically just picks up the note from underneath the robot directly into our kicker and shooter. So if there are any jams or anything, it's very easy to fix, and we can fix that with our set points. And yeah, it's been very successful for us.
It's a very smooth intake that I saw there so far. That transfer process you have works out so well for that. When you were looking at the design for it, can you just walk me through a little bit, like why was this type of intake the best fit for 2468 when you were looking at designing your robot?
Yeah, so we were looking at picking up from the source or picking up from the midline during auto. We didn't want to have to worry about other robots colliding with our intake. And if we were to have a over-the-bumper intake that stuck out and was, let's say, more robust, that had more heavier material, then it would add weight to our robot and ultimately affect our speed, which we were trying to reduce.
Fletcher, let's talk about the shooter mechanism and the pivot that you're using for that too. You know, I think about watching 2468 at your districts earlier this year. Your team has done such a great job of both not only scoring, but also passing as well too, and just a really complete design for what that is. So talk to me about what you have, and of course the big changes you made going into DCMP also.
So initially our goal was to shoot from right in front of the wing line and in that stage area. So to do that, we initially just had two motors powering the flywheels, one powering the top flywheels and the bottom, and one powering the bottom flywheels. And we weren't able to get the accuracy we wanted from distance. So we moved away from that and we wanted to add spin. So there was a few ideas we had, adding a different material on one side, or having a different material on one side of the wheels. But we found that spinning the note with a differential on the left and right was the most effective. And we had to go with 4 motors because we needed a differential on the top and bottom to score in the amp as well. So we ended up with 4. And for our pivots, we wanted a very low backlash mechanism to have that accuracy we wanted. So the way we achieve the tensioning in the pivot is it is bolted in on the bottom with a RT25 tooth profile. Then it comes along the pulley here, and then we have a ratcheting box right here and held on by an axle, and then it's tensioned by this right here. So it's kind of squeezed in between the two. And so we can twist this axle right here and tighten the belt as needed.
Can we see kind of those different states of what that pivot looks like?
Yep.
It's a very, very smooth process as it goes through that. Looks like it's working great.
Yep.
So far, love it on there. Let's pass it over to Avery, talk more about your climbing mechanism. And of course, we got to talk about adding the fan on for the trap as well too, and how it's been working out so far. Love to hear more about, first off, what made you decide to want to add the fan? Because when you look at different options for trap, the fan can be a little risky sometimes, you can go that route, but just talk to me more about what's all gone into this.
So early on in the season, like David said, we really wanted to focus on a fast and light robot. So we decided to go with the rotary climb. We thought that'd be the fastest. It's run off of a Neo and a max planetary gearbox with a max 90, and then a 18 to 48 chain reduction. So overall, it's about 333 to 1, really big. We chose this because it was the easiest to integrate, as well with the space that we had. We didn't think we had enough room for a telescope to go up as high as we wanted. For the trap, we knew we wanted to make a trap for DCMP and for champs, but we didn't start it at the beginning of the season because we really wanted to focus on being that fast and light robot and focus on our scoring. But we knew we wanted to work on it, so we were looking around at other teams and we saw the blower idea, and we decided that it was something that we could work with. We initially started with a store-bought blower that we just rigged to put a 775 Pro in, but we decided to go with something custom because it was lighter and easier to integrate for us. So this is a fully custom designed and 3D printed, basically ducted fan. It's all designed in SolidWorks. It starts off, but really what makes it work is the shroud at the bottom, which takes the vortex created by the impeller and turns it into a laminar flow, so the air can go really far, really powerfully. It's just run off of one Neo 550. So this is a little bit more powerful than like your average leaf blower at around 340 CFM, and your leaf blower is around 300. It is a slightly lower velocity, but we found that that doesn't actually make a difference for what we're trying to use it. In fact, we can actually blow open the trap from across the fields.
I never thought I'd hear like leaf blower technology or leaf blower terms when it comes into blowing game objects in FRC before. So that's always an interesting thing with that. And I really love the whole 3D print on this. It looks like a couple pieces that have been made into this so far, but I just love that ingenuity that goes into like, hey, we tried something that was COTS, but we thought that making something a little bit more of our own would be a successful route for that. So how has this been working out so far for you here at Champs?
So it's really great. Once we get the lineup down, it works really lovely. We shoot it in using the shooter and a different preset when we have the fan upright. If we can't see the tag, it's a little bit harder to line up, but we found ways to work around that.
Absolutely. Joanne, let's talk about some of your electronics that you have, and a couple custom PCBs as well too, as we go into your robots. Talk to me more about it and walk me through it.
Yeah, so basically a problem that we were seeing when we were going through wiring process and everything is, especially with swerve drives, we saw a lot of extra wire and just like a bunch of slack going on in each of these corners. And so we wanted to reduce some of that clutter that we were seeing there. And so I designed a custom PCB. And basically what this does is it acts like a little hub between all of the components. So instead of daisy chaining, like a lot of teams would do between each component, we just all connect them into the hubs, and then the hubs are connected to each other so that it makes simplifying the wiring a lot easier and debugging a lot quicker. So if we ever need to isolate a mechanism or we need to debug something, these make it a lot quicker to find and a lot easier to work with. So we also iterated that farther by making 6 and 8 position. The original one was 4, and so that's how it was connected. And we iterated that, created larger and larger ones depending on what we needed to use it for, on which mechanisms and what part of the robot.
Awesome work on that. As we continue on this, Catherine, talk to me more about your auto alignment for a trap and anything else you want to mention in regards to programming.
Yeah, so for trap, basically we have a button on the driver in which whenever he can see the trap April tag, then it'll basically take a snapshot of like all the data that we can see from the trap, such as like the 3 angles that the limelight internally gives you back and the distances. So that's our current distances, and then we have a target distance that we want to go to. So we have then we'll subtract those and get a distance, and we have a fixed time. So it's basically just a constant speed where we will go to whatever our target distance is. And then after that, the LEDs will turn green, and then our driver Fletcher will know to shoot into the trap. And in terms of programming for that, when the operator presses the Y button, the trap fan will automatically turn on and the climb arms will automatically go up and blow open the door. So yeah, then Fletcher can shoot easily into there. And then in terms of interpolation, we use a lookup table of 15 points from all the way from the subwoofer to around the wing line. And we still use this Sunlight 3. And we use the 3D targeting function in the Limelight and get the distance, and then based on those distances, set all of our presets and our hood presets, and yeah.
We got to wind up talking more about your autonomous modes and what you're doing for that so far. So even if you talk to me more about what kind of auto modes you're doing, and more importantly, what changes have you made from district championships coming into here? Because the strategy has changed so much in regards to this game. Have you made any changes in regards to trying to get to the center line quickly or anything like that at all?
Yeah, so we actually drop our preload down on the floor and then we come back and pick it up again. So it makes it a lot faster for the sprint to the midline so we can get notes faster. And in terms of auto, like Catherine mentioned, we have 2 limelights. So we have the one on the front to detect the April tags, and then we have the one on the back, which is a 2 to detect the notes. So we use the internal Python pipeline in the Limelight to do a color filter and an area filter on the note to see where it is in auto. And we also have our own custom path planner. So this is our own path planner that we created. We used LabVIEW, so I can create a new path. So we overlay our path onto the field, and between what we call these waypoints, we generate a velocity profile for our robot to follow. So if I click play, you can see the robot following that trajectory. So this makes it super easy for us to make paths because we can just overlay it on a picture of the field and our robot will travel that distance and go to that spot. And then we also have our own custom dashboard. So we have all of our pre-match configurations on here. We have all of the feedback from our shooter to our flywheels to our climb, just to make it easier for debugging. And we also have an auto selector for all of our different auto paths. If I go to match view, you can also see our Limelight camera feeds. So it makes it easy for the drivers to look at this and make sure that everything is correct. And we also have the SparkMax blink codes, which make it super easy for debugging if we have an issue in the pit.
2468, congratulations on a phenomenal season. Wish you best of luck both from the robot and also from your impact side as well too. And thanks for all that your team does for the FRC community. It's such an impactful team. Looking at all the different initiatives that you have for that, is there one initiative in particular that 2468 does that you're really proud of?
I think co-pilot is honestly really cool. Helping other teams and talking to other teams is really awesome. So.
Well, thank you for everything your team does, and phenomenal machine. I think there's a lot the teams can learn from us. Good luck here at the championships, and thanks a lot. Support funds content creators when you sign up for a membership on YouTube Join. You'll get access to special perks like emotes, loyalty badges, and fun members will even get early access to our scheduled videos and more. 100% of this revenue will go back to our correspondents to help recognize their efforts. Click the join button in any YouTube video to pledge your support.